Okay, after watching that video then you should have some idea about binary shift, sometimes called arithmetic shift. And it's all about multiplying and dividing binary numbers. So if we had this number here, now you might be asked to shift it one place to the left, or you might be asked to multiply it by 2. And both of those two things are exactly the same, as you probably picked up from the video. So if we were to left shift this binary number by one place, or multiply it by 2, which remember is the same thing, what we do is we move those numbers along and we fill in the remaining spaces that we've just created with zeros. As this one's a 0, we can kind of drop that off the end and not write it. You wouldn't lose marks if you did write it down anyway, because it wouldn't be worth anything. So that's a left shift by one place, or a multiply by 2. We might be asked to multiply it by 4 or shift a binary number 2 places to the left. So in this example, and you can perhaps do this when you're doing it on paper in your exams as well, is write out some boxes just so that you don't make any mistakes about how many places you've actually shifted it. So what we're going to do is we're going to move everything 2 places across to the left and fill in the spaces with zeros. Again, these are zeros, so we can kind of drop those off the edge. It doesn't really matter. We've not created any overflow. Now, you may be asked to left shift or multiply a number, and it might be asking you to give the value as an 8-bit number or a byte. If that's the case, then you need to highlight the fact that overflow has occurred, because we've now got ones that would be in position number 9 or onwards. Most of the time though, they're just asking you to shift bits to the left and not worry about keeping it to a certain number of bits. Okay, but you're going to need to read the question and find out sort of what it is that it's asking. So down here, say if the question doesn't ask you to keep it to 8 bits, you'd be quite okay to write this down as your answer if this was a result of your calculation. Okay, don't worry too much about this slide if you're struggling to understand it. It's not going to affect your lesson today too much. Then we'll go back over it in year 11 anyway. Okay, so don't worry too much about this, but basically you need to think of the question: have I got to stick to a certain range and identify if overflows occurred, or do I just ignore the fact that we've gone over into overflow and just carry on anyway? But that'll be down to the question. So right shift then, this is obviously dividing now because we're going to the right. Think logically, we're making our binary number smaller, so we're not going to be multiplying it by anything, we're going to be dividing it. So sorry, go back to the previous one. A 1 shift placed to the right, if we were dividing this number, would give us 3 zeros. The 2 ones would have moved across, and we've got 1 0 on the end. Remember, anything after the sort of 1 position disappears, as it shows you in the video. 2 places to the right would of course move those 2 ones across all the way over here, which is the equivalent of dividing by 4. Remember though, back on the video, when they tried to divide 208 by 32, mathematically we should get 6.5. However, if we moved it across like they did, we're losing some precision because we've now had to delete one of these ones off the end, which means that our answer only comes to 6. And this is only going to make sense obviously if you've watched that previous video. So we now have said that actually 208 divided by 32 is 6, which isn't entirely correct because it should be 6.5. So what we've done there is we've lost some precision, and that is called underflow. So the loss of precision is called underflow. We're unable to represent the number in the bits available, so the result of the division is not a whole number. Okay, another example down here, 9 divided by 2 should be 4.5. If we do that with a binary shift, we drop a 1 off the end and our answer is 4. So 9 divided by 2 looks like it's 4, which is wrong. So the underflow flag would be set to true, indicating that an underflow error, has taken place. Right, you should now be able to work through the rest of lesson 5, answering all the questions. There is one question that might give you a little bit of trouble, which if I open this up here, it will be this one. Don't worry about doing this question here. Okay, I'm going to leave it in because at some point we're going to come back and do it, but it's easier to explain when we're sort of all together. If you feel you know the answer to this question using the power of etc, then answer it. If not, don't worry about that. So that's part of task 3. Okay, so ignore that part there unless you really are confident with your to the power ofs etc. So work your way all the way down. Then do the summary, a quick summary there, and then you can do the extension task, which is to add overflow, underflow and binary shift to your binary guide and re-upload it down here below. Okay, that should give you plenty to do. If you finish, you can of course go to your component 2 exercise book and you can work on any of these solving problem tasks down here. Okay, good luck.